Hey there, science fans. Have you ever wondered what holds everything together? Why doesn't everything just fall apart? The answer is chemical bonding. It's the amazing process that glues atoms together to form molecules. These molecules make up everything around us, from the air we breathe to the water we drink. Without chemical bonding, our universe would be a very different place. Let's dive in and learn about the different types of chemical bonds. Atoms are like tiny building blocks. They have a nucleus in the center with protons and neutrons. Buzzing around the nucleus are electrons. Atoms want to be stable. To be stable, they need a full outermost shell of electrons. This is called the octet rule. To get a full outer shell, atoms share or transfer electrons with each other. This process of sharing or transferring electrons is what we call chemical bonding. Remember how magnets attract when they have opposite poles? Ionic bonds are similar. They happen when one atom gives an electron to another atom. This creates ions, which are atoms with a positive or negative charge. Positive and negative ions attract each other, forming a strong ionic bond. Table salt is a great example of an ionic bond. Sodium gives an electron to chlorine, creating Na+ and Kl ions that stick together. Covalent bonds. Sharing is caring. Sometimes atoms prefer to share electrons instead of giving them away. This is called a covalent bond. Think of it like sharing your toys with a friend. In a covalent bond, atoms share their electrons to achieve a full outer shell. Water, H2O, is a perfect example of covalent bonding. Oxygen shares its electrons with two hydrogen atoms, forming strong covalent bonds. Metallic bonds. A sea of electrons. Metals are shiny and malleable. Why? Because of metallic bonds. In metallic bonds, metal atoms share their outer electrons with all the other metal atoms around them. These electrons are free to move around, creating a sea of electrons. This sea of electrons makes metals good conductors of electricity. It also allows metal atoms to slide past each other, which is why metals are bendable.